For years, Chevrolet 6.2-liter 8 has been one of the most respected engines in the American truck and performance world. Found in vehicles ranging from the Silverado 1500 in Tahoe to the Camaro SS and Cadillac Escalade. This small block V8 earned its reputation through strong low-end torque, smooth power delivery, and classic V8 durability. But despite its strengths, one persistent issue began to tarnish its legacy: premature bearing wear. Owners, technicians, and engineers started noticing a troubling pattern. Certain 6.2-liter V8 South, especially newer versions equipped with advanced fuel-saving technology, were experiencing bearing failures far earlier than expected. In some cases, engines failed catastrophically at surprisingly low mileage. Lawsuits followed, online forums filled with horror stories. Confidence in one of Chevy's flagship engines began to erode. Now, according to internal updates, supplier changes, and expert analysis from engine builders and dealership technicians, Chevrolet has quietly but decisively fixed the 6.2-liter V8 bearing issue. The changes aren't flashy, and you won't see them advertised on a dealership window sticker. But mechanically, they're significant. In this video, we're breaking down what went wrong, what Chevy changed, and why experts believe the updated 6.2-liter V8 is once again a trustworthy powerhouse. The Chevrolet 6.2-liter V8 is part of GM's legendary small block engine family. For decades, this architecture has powered muscle cars, trucks, and SUVs with remarkable consistency. At its core, the design emphasizes compact packaging, high torque output, and especially in modern versions, bearings play a critical role in this system. Main bearings and rod bearings support the crankshaft and connecting rods, allowing them to rotate smoothly at thousands of RPM under extreme loads. When bearings fail, metal grinds against metal, oil pressure collapses, and engine destruction follows quickly. According to veteran engine builders, bearings are not wear items in a healthy V8. Under normal conditions, they should last the life of the engine, often well beyond 200,000 miles. When bearings fail early, it almost always points to deeper issues involving materials, lubrication, or manufacturing tolerances. That's exactly what began happening with certain 6.2-liter engines. The issue didn't affect every 6.2-liter V8, but it occurred frequently enough to raise serious alarms. Many reports involved engines with fewer than 60,000 miles, sometimes even under 20,000. The symptoms were usually consistent: knocking noises, sudden drops in oil pressure, metal shavings in the oil, and, in worst cases, complete engine failure. Independent teardown analysis often revealed excessive rod bearing wear, with signs of overheating and material breakdown rather than normal, gradual wear. Importantly, dealership master technicians noted that these failures weren't caused by abuse or neglect. Oil changes were done on time, engines were stock, vehicles were driven normally. That pointed away from owner error and toward design or manufacturing shortcomings. Most experts now agree that bearing failures weren't caused by a single flaw, but by a combination of modern engineering compromises, GM's active fuel management AFM and later dynamic fuel management DFM systems deactivate cylinders under light loads to improve fuel economy. While effective on paper, these systems introduce rapid changes in oil flow and load distribution inside the engine. Bearings don't like instability. Frequent transitions, especially at low RPM, can thin the oil film and increase the risk of metal-to-metal contact. To meet modern fuel economy and emissions targets, GM moved to lower viscosity oils. While thinner oil reduces friction, it also provides less cushioning under high loads. Lubrication specialists point out that when bearing clearances and oil viscosity aren't perfectly matched, even small manufacturing variations can become a serious liability. Industry insiders report that certain bearing batches simply didn't hold up well under real-world stress, particularly in high-torque truck applications. Modern bearings rely on layered materials to balance strength, beatability, and heat resistance. If that balance is even slightly off, wear accelerates rapidly, rather than making a public spectacle. Chevrolet addressed the issue through internal engineering updates, supplier changes, and revised specifications. Updated 6.2-liter engines now use bearings with revised overlay materials and improved heat resistance. Engine builders examining these bearings report better wear characteristics and greater tolerance for oil. Starvation, events especially during cold starts and low RPM operation, where many failures previously occurred. Chevy also tightened manufacturing tolerances, reducing the likelihood that engines leave the factory with marginal oil film protection. As one GM-trained technician put it, you just don't see the borderline cases anymore. While the oil pump design remains similar, updated calibrations help maintain more stable oil pressure during cylinder deactivation transitions. This is especially important for trucks and SUVs that operate under high torque at low RPM that put maximum stress on bearings. Unlike some past fixes that merely treated symptoms, experts believe Chevy's solution addresses the root causes. A veteran engine builder with over 30 years of experience summed it up this way: the 6.2 wasn't a bad engine. Modern efficiency demands just pushed it too close to the edge. Chevy pulled it back with better materials and tighter control. Lubrication engineers agree, noting that with thinner oils and complex systems, modern engines have far less margin for error than older V8. For buyers considering a Silverado 1500, Tahoe, Suburban, Yukon, or Escalade with the 6.2-liter VOA2, this update matters. Experts now agree that newer production engines are far less likely to suffer bearing failures. Dealership technicians also report a noticeable drop in bearing-related warranty claims, the clearest sign that a fix is real and effective. For owners of earlier engines, the picture is more nuanced. Many have already logged high mileage without issues, and not every engine is destined to fail. Still, experts recommend precautions: more frequent oil changes than factory intervals, high-quality oil that meets or exceeds GM specifications, avoiding excessive idling under heavy load, listening closely for early knocking or oil pressure warnings. Some owners also choose to disable cylinder deactivation systems where legal, though this can affect warranties and emissions compliance. The bigger picture: the 6.2-liter bearing issue highlights a broader challenge facing modern V8 South. They're expected to deliver old-school power alongside modern efficiency, emissions compliance, and reliability all at once. Chevy's response shows a commitment to refining the V8 rather than abandoning it. By improving materials, tightening tolerances, and refining lubrication behavior, GM demonstrated confidence in the future of the small block platform. The story of the 6.2-liter V8 bearing issue is ultimately a story about engineering limits and how manufacturers respond when those limits are pushed too far. Chevy made mistakes. The failures were real and costly. But instead of ignoring the problem, the company fixed it properly. For enthusiasts, truck owners, and longtime Chevy loyalists, that matters. The V8 still has a future, and the 6.2-liter once again stands as a reminder of what American engineering can achieve when durability is treated as seriously as efficiency. In short, Chevy didn't just patch the problem. They fixed it